Hey everybody, welcome back to another lab walkthrough. Today's lab walkthrough is talking about the average atomic mass of Marshmallowium lab. So like always, you have background information full of very important information. So here it kind of gives the backstory as to what we are doing. You have some atomic structure basics in case you forget what an atom is made of. And then the new stuff as of now, isotopes and average atomic mass. So if those words are new to you, definitely take a look at that section. First question is based on reading this scenario, whether or not you agree with it. So at your lab station, you'll find a few things. You'll find a scale, and you'll find a bin of marshmallows. So your first job is to take the scale and to turn it on. It should light up, and it should be 0. If it's not zeroed, you can just click that 0 button right there. So you have 2 bags of marshmallows. One says do not open, so don't open it. The other one, you can open. This is the bag in which you are going to measure your 3 marshmallows. So on your lab sheet, it tells you to look at the green, the orange, and the blue one. So you'll take each marshmallow, take the green one, throw it on in the middle, and whatever mass it says, record that on your data sheet in the column that says average atomic mass, or atomic mass AMU rather. Once you do that, remove it, take out the next one. The next one is orange. It has an orange dot, it's more of a square. Throw that up, look at the mass and record it. Throw that onto the atomic mass section. And then lastly, you'll take the blue one. It's the largest one with a blue circle on it. Throw that on and record that mass. Once you have all of that, put those 3 marshmallows back in the green bag and zip them up like this. So we have from our measurements, our green one is about 6.4. Our orange one is 14.8. And our blue one is 25.1. And we're going to just use the AMU feature or unit for this. So our mass number, we're going to round all that to the nearest whole number. So that becomes 6. This becomes 15. And that stays at 25. So with that, you're able to do the rest of the table. This column, if you're not quite sure what to do, check out again that paragraph. Calculate the numbers of protons, neutrons, and electrons. If you're not sure about that, check the atomic structure basic section. So now we have to calculate the percent abundance of each thing. So using the tape bag that says do not open, that is this one, your job is to count the number of each different type of marshmallow. So here we have 1, 2, 3, 4 blue ones. We have 1, 2 orange ones, and 1, 2, 3, 4, 5, 6, 7 green ones. So as per our measurements, we had 7 green ones, 2 orange, and 4 blue. And together, if we add all of them up, we get 13. So each one of these things is our part. We can even change the color here. And our whole is 13. And so when we do part over whole, for example, it would be 7 divided by 13. Whatever that equals, write that down to 4 decimal places. Whatever that is, and we can even do that. So if we do 7 divided by 13, that equals 0.5384. When we times that by 100, it becomes 53.84, and that is our 53.84%. So you do that for the remaining thing. All of your percent should add up to 100. If it's a little above, a little below, that is okay, but if it is very off from 100, you need to go back and figure out what happened. Now, once you have that, we're going to calculate the average atomic mass. So the percent abundance goes in here. So this number goes there, and every other number that you calculated goes here. Here we're going to convert this to a decimal, And so to do that, all you have to do is divide by 100 or move your decimal spot over 2 spots. So that is 0.5384. And then this column, the average atomic mass, is what you have from table number 1. So once that's all filled in, you have all the information that you need. So you'll plug into this formula and this formula. There are 2 different ways to do average atomic mass. As long as you're familiar with both, that is cool, but you need to be comfortable doing one, but be able to recognize both of them. And then you'll have your actual average atomic mass, and you'll calculate a percent error question. And that is your lab. Have fun.